So in the last lecture, we studied about mesh analysis using dependent sources. So let's start with nodal analysis using dependent sources. So let's take an example. Find the voltage across 5 ohms in the network shown. So where is 5 ohms? Here. So we have to find the voltage across this 5 ohms, right? So what is the voltage across this 5 ohms? So if you see, this is the node V1. It is already given. So voltage will be same as V1. So in short, we have to find V1 only, right? Because this is ground. So V1 is nothing but voltage across 5 ohms, right? So what we do, we have to use node analysis. So we'll assume all the currents are going away from the node, right? So let's start from here. So if I take this current I have assumed outgoing, but this is incoming. So this will be what? -2 plus like this. So V1 upon 5 plus like this. So V1 plus 30 I1 upon 10. So V1 plus 30 I1 upon 10. So remember, this is a voltage source, dependent voltage source. So don't get confused with this current, thinking that it is a current source. Plus minus indicates it is a voltage source. So upon 10 plus V1 minus 50 upon these two are in series. So 20 plus 10, 30. You can write directly 30 equal to 0. So if you now observe, we have only one node. So using node analysis, we know number of equations is equal to number of nodes, right? So, but we have two unknowns, means we have to write this I1 in terms of V1. So how to write that I1 in terms of V1? So I1, you know, it is here and it is here. So from here, so you can write from the network I1. How is it flowing like this? So I1 is V1 minus 50 upon 30. So V1 minus 50 upon 30, because I is V by R by Ohm's law. So substitute here. So therefore minus 2 plus V1 upon 5 plus I'll separate this plus V1 upon 10 plus 30 upon 10 is 3. So 3 times V1 minus 50 upon 30 plus V1 minus 50 upon 30 equal to 0. So we will just have to solve this equation and we'll get V1. So calculate the terms in V1. So 5 inverse plus 10 inverse plus 3 by 30 inverse. So it should be in bracket 3 divided by 30 whole inverse plus 30 inverse will do. Yes, 30 inverse. Is anything remaining? No. So 31 by 3. So I'll write here. Therefore 31 by 3 V1. Then all the constants. So minus 2. This is minus 3 into 50 upon 3. Minus 3 into 50 upon 3. This is minus 50 by 30. Minus 50 by 30. So equal to 161 by 3 towards the right side. So therefore V1 equal to divided by 31 divided by 3. So 5.1935. 5.1935 volts. So this is the required answer. So finally we'll write, therefore voltage across 5 ohms equal to V1 equal to 5.1935 volts. So this is the final answer. So this is the way you have to solve this up. So let's take a next term. For the network shown, find the voltage Vx. So this is Vx. So again, I assume all currents are going away. So again, we go like this. So this is in opposite direction. So minus 0.6 plus Vx upon 100. Then this is what dependent current source. So we are going in opposite direction again. So minus 25 Iy plus Vx upon 50 plus Vx minus 0.2 Vx upon 40 equal to 0. So again we will have one extra term, that is Iy. So Iy we have to write in terms of Vx. So current Iy is like this. This whole node is Vx because it is shorted. So Iy is Vx by 100 from network Iy equal to Vx upon 100. So therefore minus 0.6 plus Vx upon 100 minus 25 into Vx upon 100 plus Vx by 50 plus Vx minus 0.2 Vx upon 40 equal to 0. So we have one equation, one unknown, so we can find Vx. So collect the terms in Vx, 100 inverse, this is minus 25 by 100, so minus 25 by 100 plus 50 inverse plus 40 inverse minus 0.2 by 40. So minus 1 by 5 Vx minus 0.6, this is the only term, so equal to 0.6. So therefore Vx equal to 0.6 into 5, 3. So and this is negative, so minus 3 volts. So Vx equal to minus 3 volts. Find the voltage Vx. Right. So make sure you practice these sums. And use calci also. It is very important. So let's take the last sum. Find voltages V1 and V2. So now here you observe there are two nodes. They are already given. So again you have to write. Remember, I have not written it. Applying KCL at node 1, applying KCL at node 2. So again let's assume all are going away. So again this is in negative direction. So minus 2 plus V1 minus 20 upon 20 plus what will this be? V1 minus 0.5 V1 minus V2. You have to go till the other node. We are always ending towards the other node. Minus 20 here we ended till this node, reference node. So here also we have to end till this node. So V1 minus 0.5 V1 minus V2 upon 5 plus, that's it. That is for node 2. So equal to 0. So we have two equations, two unknowns. Correct? Yeah. So collect the terms here. So 20 inverse plus 5 inverse minus 0.5 by 5. 3 by 20. So 3 by 20 V1 minus 5 inverse for V2 minus 0.2 V2. Then this is minus 2 minus 20 by 20 minus 1. So here it will be 3. So this is equation number 1. So now if you have a doubt, why haven't we converted V2 in terms of V1? V2 is not a dependent quantity. What is the dependent quantity? V1. So V1 is already here. So we don't have to express it in this case because it is the same as the node itself. Then applying KCL at node 2. So again assume all are going away. So V2 plus 0.5 V1 minus V1 upon 5 plus V2 upon 2 plus V2, what will this be? V2 minus 40 upon 10. Then this is in negative direction, so minus 4 equal to 0. So therefore collect the terms in V1 is 0.5 V1 minus V1. So 0.5 minus 1 is minus 1. So I'll directly write minus 5 inverse. And that's it. So minus 0.2 V1 5 inverse plus 2 inverse plus 10 inverse plus 4 by 5. Otherwise you can write 0.8. It's fine. V2 equal to, this is minus 4. Minus 4, here it will become 8. So two equations, two unknowns. So therefore V1 equal to, V2 equal to, solving equations 1 and 2 simultaneously. That you have to write. So 3 divided by 20 minus 0.2, 3 minus 0.2, 4 divided by 5, 8. So V1 is 50 and V2 is 22.5 volts. I forgot the unit. Don't forget to write the units. They carry 1 mark each. So this is the way you have to solve sums on nodal analysis. So next lecture we'll discuss super mesh and super node analysis.